Hello everyone. In this video, I'm going to show you how to create a Modbus communication between IoT250 and NodeRed and S7 CPU. So I have my TI portal open here. So creating a new project. In this example, CPU would be our server and NodeRed would be our client. Okay, adding a new CPU. So I have a 1500 CPU and I'll let TI portal to identify that. The IP address of my IoT device is set by default as 192.168.200.1. To make the CPU in line with that IP address, I set the IP of my CPU to 200.20. Now I have to configure this CPU as my Modbus server. To do that, we can use the Modbus TCP library that is integrated in TI portal. So I'm going to open the main block. And then in the library, under communication, others, I can find Modbus TCP folder and take the Modbus server function block and drop it in the menu. Okay, so all I need to do is to configure these parameters and I'm good to go. So the first part is disconnect. I don't need it for this example. Next one is holding registers. That's where we define the area for our Modbus holding registers. The easiest way is to create a data block to do that. So I'm going to create a DB, add new block, and I call it data. Define an entry as registers. And I can simply create an array of integer since each register is a 16-bit. So let's say an array of 0 to 10. And to be able to read the data in the NodeRed, I'm going to initialize some registers with some starting values. Okay, good. So now I have to set that in my main OB. I'm going to split the screen to be able to see both blocks. And I can simply drag and drop these registers and drop it here. Okay. So now we have defined our holding register area. Okay, next I have to go to other parameters. So all I need is connect, error, and a status for this example. To manage these parameters, the easiest way is to create a data block to store them all together. So I'm going to create another DB. And I'll call it config. Okay, the first one is connect. Connect is a type of variant, so it's a special data type. You can find the details in the help of the function block. So if you go and open the help, so the description of connect. So here it tells us, okay, what type it is. It's a data type. It's a special user-defined data type, TCON IPv4. So you can copy paste this. And I need to define error, which is a Boolean. And a status, which is a word. Okay, so we have defined what we need. Now I have to set some parameters in the connect variant. So expand this structure, and starting from the top, interface ID, that refers to hardware identifier of the port from the CPU. So we can find that in device configuration. We click on the port properties and system constant. So it tells us, okay, the Profinet interface has the hardware interface ID of 64. Okay. ID refers to the Modbus communication channel. For each channel, we have to specify an ID, and we can start from one. Connection type could be either TCP or UDP. If you scroll to the right, you can see it in the comment. So for TCP, which we're going to use, it has to be set on 11 and in hex format. So it's going to be 16. You don't need to change this one. Then the important part is the IP address of the client. So our client is the IOT2050, which has the IP address of 192.168.201. And it's not important what port is used on the client side, but on the local part, the server is, by default, is port 502 for Modbus TCP. So that's set and all good. So all I need just to connect this variable to the input of the function block by simply drag and drop, and the same for error and status. Oops. Okay, so I'm going to save and compile my project. All good, and download. Okay, so I'm going to activate the monitoring, see what's going on. So, okay, all good, everything is green. Status is 7002, which means that this server is ready and is in the kind of listening mode and is ready to receive requests from clients. Okay, so everything is good here. Now I'm going to configure the NodeRed side. So I'm open my browser and go to NodeRed. So in NodeRed, there is a node library for Modbus. If you haven't there in your NodeRed, you can simply install it in the Manage palette and go for NodeRed contrib Modbus, and you get all this block. So what I'm going to do now is I'm going to read those registers that we have configured in the CPU. So I need a Modbus read, and to see what's happening, I'm going to use a Modbus response and then connect to read response. That will display the status of each action or job. So now we need to configure the Modbus read node. So open it up. We have to start from the bottom by setting up the server settings. So click here. And our server is the CPU, which sits on 192.168.220, and default port is 502. We can give it a name, S7 server, and it uses the type TCP as we set there by default. Okay. So now we need to specify what we want to do by choosing the right function. So we're gonna read some registers. I'm gonna choose Modbus function 3 and specify the start address for reading the registers. So that was the address. I'm going to read from this address, which is address 2. And I'm going to read 3 registers. And we can define like a polling rate to read it like every, let's say, 5 seconds. Okay, that's all. Done. And deploy. And you see the status, it's connected. So if I wait for 5 seconds, you see the readout shows up here. So I'm reading those 3 . Let me resize my screen. I'm reading these 2 registers, and it shows up in the form of array here. So if I change this, change the variables here, we can see that in the NodeRed side. So make it 202. 33404. And after every 5 seconds, these values would be updated. And now I'm going to do a write function. Again, I'm going to connect another Modbus response to see the status. So for the Modbus write, let's say we want to write on register 5. So I have to pick the function writing on a single register, FC6. The address is 5. And I'm using the same server. Okay, done. So now I have to pass a value to the right. So I can use inject. And change it to number. And let's say I want to write 505. Okay, deploy. So let's resize the screen. So here is my register 5, which is 0. As soon as I trigger this write function, so you see that it sends this Modbus command. The register on the CPU is updated. Okay, so that was it. I hope you enjoyed it. Thanks for watching this video. Bye-bye.